I'm Anil Kumar sharing with you a test question on functions. This is for the students who are preparing for calculus, so it could be a part of pre-calculus also. The question here is, find domain and range of f of x equals to square root of 1 minus 3 to the power of x minus 2 divided by x plus 2 times square root of x squared minus 1. You can always pause the video, answer the question, and then look into my suggestions. Now, as you see, this is a very complicated function. It is, you can say, combination of few functions which you have learned, right? So let's break them apart. Let's see what functions are we talking about. So one of these functions is square root of 1 minus 3 to the power of x minus 2. That's on the top, and then we have this other function which I will write as 1 over x plus 2, and then the third function could be written as 1 over square root of x squared minus 1. So it's product of these three, right? So basically we could write f of x as product of these three. So when you multiply this, you get your function. Now domain and range of this function will be intersection of all this. So domain is set of all the elements which are common in all the three, right? That is what it is. So we need to analyze each and every function individually to get the domain and range of this particular function, correct? So that's the whole idea. So let's begin by analyzing the first one, which is extremely complicated. So what we have here is, let's say this is a number line, right? We'll just work on domain first, and then we may even sketch the function if time permits. So it could be a lengthy video. Now what you notice here is that this part is 1 minus something. Now a square root is always positive, so range part we are clear, it is greater than or equal to 0. So range is clear in this case. The domain is tricky. 1 minus 1 is 0. And anything to the power of 0 is 1. So think about logic, right? So I'm not writing here since you are an expert by now. So if x is 2, 2 minus 2 is 0, right? So I get 1. So that becomes a limit for this. So at 2, it works for us. The function will give me a value of 0, right? Now you could also use calculator and the knowledge of transformations, correct? So, or sometimes combination of the two. Okay, so let me add things which I'm talking about. Okay, that's fine. So let me make a small sketch here. Okay, that will help actually. So, okay, no problems. So what we have here is 1 is kind of a constant. 1 is just a constant, right? So 1 is this. 1 is this, which is a constant. Okay, right. And we have to take away from this function, let me put it in red, take away minus. Minus means it is going to be, we'll take away, so we'll not consider minus, but no, 3 to the power of x minus 2. So it's an exponential function which has been moved 1 unit to the right. So 1 for that function has been moved 2 units to the right, right? 2 units to the right. So that function will be kind of like this. So this point is at 2, right? So this function basically is, the red one is 3 to the power of x minus 2 for us. So 3 to the power of x minus 2. And when you say combination, we want this red thing should be below one line. If it goes over, then inside the radical part will get negative part. Do you see that? 1 minus that will give me negative, 1 minus this is positive. And so clearly, the domain of this function will be kind of like this. Is it okay? Domain of this function will be kind of like this. And if you really want to sketch the function, if you sketch it, that is the difference of these two. 1 minus this, and then square root, and then square root. So if I put 0 here, it will be slightly less than 1. So the sketch will be kind of like this. Okay. Do you see that? The sketch of this function will be kind of like this, where this value is 1 and slightly less than 1, and it moves. So that becomes the function square root part. Is it okay? I hope that's clear. Now let's get back to the second one, which is 1 over x plus 2, and that's relatively simple. We know it's a reciprocal function where denominator cannot be 0, right? So x is not equal to minus 2. So here what you get, your domain is, let me write down clearly. So domain is that x should be less than equal to 2. And in this case, we know x is not equal to 2. Minus 2, I should write. Minus 2, okay? So in this case, let us say this is minus 2 for us, right? So it's good to write somewhere here 0 also, right? Somewhere here 0, so that you know how it is going, right? So minus 2 here, then the domain is everything but minus 2. That becomes the domain, right? So it is x belongs to all real numbers but not equal to minus 2. Now how about the third one? We need to analyze this one a bit more so that we get an idea what should be the domain of this function, right? So as we did for the top portion, we'll analyze this. So we'll actually again break down into smaller pieces and then do the needful. So it's a good idea to sketch the x square minus 1 graph first. So this part, okay? X square minus 1 means a parabola which goes like this, right? So that is the parabola. Within square root, we should have non-negative, and that means, let me write this value as plus and minus 1, right? Zeros will be at minus 1 and plus 1. Now, to find the domain of this function, what is important here is that x square minus 1 should be greater than 0, right? It cannot be equal to 0 since it is in the denominator. Perfect. So what we have is x square minus 1 is greater than 0. From here, it is very clear that it should be greater than 0 means this. Is it okay? So we don't even have to do much work, but a sketch clearly indicates what we are getting into. Perfect. So in this particular case, the domain of this function will be going outwards from plus and minus 1. So that becomes the domain of this particular function. I hope it's absolutely clear. So, so we have now 3 parts, and we are looking for a common domain. Now, what is the common domain? That is your answer, right? So let's figure out the common domain here. Okay, so let's use the center space to figure out the common domain. As now, since we have all the parts here, I can actually sketch each function also. Let me begin with the center one. It says vertical asymptote at minus 2, and then this function, we didn't give a color to this, so let me give a color to this now. Okay, so let me say green color. Okay, so we could like kind of sketch this function as kind of like this. Okay, so that is the center part of the function. Is it okay? That is my function. And now we'll sketch this function. So square root means this is x square, 1 over square root, 1 over square root of this. So when it becomes positive, square root will be positive. So this point is 1 for us, and this point is not included. So from 1 onwards, the function will be kind of like this. This is from 1, okay? So this is from 1, the function will be kind of like this. So that is for the third function, which is 1 over square root part. So this is minus 1 and plus 1. Is it okay? Now let's get back to this one, which I will sketch in a different color. Let this be the color. Okay, so this is fine. So we are trying to sketch this function now in this color. The sketch is right there, right? So we know it is starting from 2, where 2 is included. 2 is included, okay, and it goes kind of okay. So let me see. If I put 0 here, I get this value as, if I put 0, well, this is not valid, but this function, if I put 0, it is half. So it is kind of going like this, right? So that is your function, right? Now what we figured out that this point is 1, right? Slightly less than 1. This point is 2 for us. So we have all the 3 functions on this graph, fortunately. That may not be case always, since you could get more complicated function than this, okay? So don't be scared about it. But if you break it down, it becomes simpler. Now let's look into the common domain. Now since this is not in that part, so that is not at all common. But beyond this we could go. This is on the left side. So one of the domains we're talking about is this. This is a common domain. Do you see, going left and reaching this place, that's common. Then if you start from here, you could go, all the 3 lines are there, but you have to stop here, right? So this is kind of a hole, and then you could go. Do you see that? That becomes the intersection of all the 3 domains. So from here, we can write domain of the function as, I hope you are with me in this, right? Minus infinity to this point, correct, which is minus 2, which is because of this function, minus 2. So you cannot include minus 2, union. And then you can include from minus 2 to minus 1, right? So from minus 2 to minus 1, again, minus 1 cannot be included, since that will result into 1 over 0, right? So that cannot be included. And then union. Now in between, this function's domain is not there, right? That is negative. And after minus 1, it can be up to 2. That's common to these 2. So it could be from minus 1, but you could include 2. That is important, right? So you could include 2. So this closed bracket means you could include 2. Now can you help me write down the range for this function? Now range is normally very difficult, since in this case we have sketched them all. What we see here is that this function is less than 0. However, we do have a value at 0, and then we have a function greater than 0. So the range in this case is from minus infinity to plus infinity, or you could say x belongs to real numbers, right? In this particular example. I'd like you to go through this video once again, review the contents which you find difficult with. If you find difficult to sketch this diagram, you should explore exponential functions and their transformations, right? If you find this difficult, you should explore the related context. I'll provide you with some links to do the needful. But I hope that gives you a good idea of what we have learned in our first unit of functions. This will be very helpful for all pre-calculus students. I'm Anil Kumar. If you like, you can put some likes. You can always share and subscribe to my videos. Feel free to ask questions. Thank you and all the best.